Hi friends, good morning. Welcome back to another session. So in the previous classes we have seen the introduction part regarding the design of steel structures, and we have seen some of the properties, advantages and disadvantages. Okay, what is the limit state method and some of the loads and their combinations as per different codes we have seen, and we have seen the importance of IS 800 2007, and the video lecture on 6th dated video lecture, it is regarding the design of fillet welded joints. In that we have seen what are the different types of welded connections along with the advantages and disadvantages of welded connections, and we have seen the specifications of fillet welded joints. Okay, so if you go back through those formulas, today we'll try to solve 2 to 3 problems based upon those formulas. Okay, so here this is a question given: find the design strength of fillet welded joint whose length is 220 mm and the size of the weld being 6 mm. Take ultimate stress in the weld as 410 MPa or Newton per mm square. Assume welding is done in the shop. So this is the question. So we'll try to solve now. Very simple question. You may expect this question for 3 marks in your external examination. Okay, so first we'll try to write the given data from the question. What is the length of the weld given as? It is length of weld equals to how much it is? (220 mm). Length of weld, LW or small l you can write, right? Next, what is the size of the weld? This is the ready-made question. Ready-made question in the sense size is given, length is given. Only thing is, all from the given data you are supposed to calculate the design stress in the weld and design strength of the welded connection, right? Next, what is this FU? What is this called as? Ultimate stress in the weld. Ultimate stress in the weld. What is it is denoted by FU, which is equals to 410 Newton per mm square. Now, assuming welding is done in the shop, now what will be the partial safety factor? That is gamma MW. For shop it will be 1.25. For site it will be 1.5. We have discussed in the specifications. Okay. Next, now we calculate. So up to this it is a given data. Now we'll calculate design stress in the weld. It is denoted by what? FWD. FWD equals to FU by √3 into gamma MW. Now if I solve this one, FU is what? 410 divided by √3 into this one is what? 1.25. Okay, now (410). So how much you are getting? 189.37. Okay, stress it is. We will be getting in what? Newton per mm square. Okay. Next, design strength of welded joint. Okay, design strength of welded joint, which is equals to 0.7 into, yes, this is effective throat thickness, into length of weld multiplied by, okay, FW. This is the stress, this is nothing but area of weld. Okay, this is throat thickness multiplied by the length, you will be getting what? Area multiplied with the stress, you will be getting the load, that is strength. Okay, which is equals to, if I substitute here 0.7 into, what is S? S is given as 6 mm. Sorry, 220 is the effective length, and stress what we have calculated is, okay, now if I solve this one, 0.7 into 6 into 220 into 189.37. So how much you are getting? Which is equals to 174.97 kilonewtons, or 174.97 into 10 power 3 newtons. Okay, this is almost you may expect for how many marks? 3 marks. 3 marks question it is. We'll see one more question. See, find the safe load transmitted by the welded joint shown in the figure. Given size of the weld as 6 mm, FU as 410, and welding is done at a workshop. So again we'll try to write the given data. So what is S is given as, again 6 mm. Next FU ultimate stress in the weld is 410 MPa. Okay, and it is done at what? Workshop. So gamma MW will be what? 1.25, and from the figure you can see the length of the weld. Length of weld is equals to, here it is done, here it is done, here it is done. So 80 plus 60 plus again 80. So how much? It is around again 220, just like our previous problem. Okay, now again what you are supposed to do? Same problem. Okay, what is that you are supposed to calculate? Design stress in weld. Weld, how it is denoted? FWD equals to FU by root 3 into gamma MW. So same 410 by root 3 into 1.25, you will be getting around what? 189.37 Newton per mm square. Next, design strength or load transmitted. Design load transmitted by welded joint is how much it is? 0.7 into S into LWD into FWD, which implies 0.7 into, what is S? Thickness of weld 6 mm. Sorry, size of the weld is 6 mm and length is 220 into, okay, FWD is 189.37. So same you are getting just like previous problem. Now, but what is the difference? What is the difference between this problem and this problem? When the values are same, everything is same. The only thing is, in the question they asked you find the safe load transmitted by. Okay, so safe load transmitted means as per limit state design, the safe load is ultimate load by factor of safety 1.5. okay, so that is the safe load. So how much you are getting? 116.65 kilonewtons. This is the safe load that the joint can be carrying. Okay. Yeah friends, this is one more problem which is somewhat essay type question. Means you may expect this question in a long answers. As per CET curriculum, you may expect this for I think 5 marks are you are getting. How much I don't know exactly as per new curriculum. So coming to here, two steel plates, okay, of 250 mm by 12 mm size are connected together at their ends by 10 mm size end fillet welds. Okay, the connections are made in the site. Ultimate stress in the weld is 330 Newton per mm square, and determine the design tensile stress in the plate. Now two plates connected together at their ends. Okay, one plate is like this, one over the other, and the weld is done in this place, only ends. If we go for a plan view, this is 250 mm. Okay, now we'll first, as usual, we'll write the given data. What is given? Size of weld, S equals to how much? 10 mm. Next, plate sizes, how much it is? 250 by 12 mm, right? Now what will be the length of weld, which is equals to this one, this much of length, right, which is equals to width of plate, that is L. This is what? L. Now in general, even though if you are welding up to the ends, you are supposed to consider effective length only. So in the specifications of design fillet weld, you have seen what is effective length formula. What is that effective length formula? Effective length of weld LW equals to actual length minus 2 times the size of the weld. It should not be exceeding 4 times of S. It should not be less than 4 times of S. That is the condition. So what is the actual length of the weld? 250 minus 2 into size of the weld is 10. So 20 means 230 mm. Now your length of the weld is 230 mm. Next, what is given? Ultimate stress in the weld is given as 330 Newton per mm square, right? Now it is done at what? Site. Now because of it is done at site, the partial safety factor gamma mw will be equals to how much? 1.50. 1.50, right? Next, design shear stress in weld how it is denoted? FWD equals to FU by root 3 into gamma MW. Okay, if I substitute this one, what you will be getting? What is FU? 330 divided by root 3 into 1.50. Okay, so root of 3 into 1.5, so 330 divided by value. How much you are getting? 127.01. So 127.01 Newton per mm square. So see 127.01, right? Now design strength of weld joint. Design strength of welded joint or plate is what? 0.7 into S effective throat thickness multiplied by length of the effective length of the weld. This will be the area multiplied with the stress. So 0.7 into 10 into 230 into what is this? 127.01 Newton per mm square. 0.7 into 10 mm size of the weld into 230 into 0.01. So how much you are getting? 204.48 into 10 power 3 newtons. Okay, now up to here this is the what? Strength of weld. But see here, if I take this joint, here it is welded, here it is welded, means two sides welded. Now design strength of this is single weld. Now design strength of welded two sides, right? Strength of two welds. Okay, so 2 into 204.48 into 10 power 3. So how much you are getting? 408.97 into 10 power 3 newtons, right? But see here we designed, but he is asking to find out the design tensile stress in plate. Now stress equals to load by area, am I right? So design stress in plate, so which is equals to, this is the load divided by area of plate. What is the area of plate? 250 into 12 mm. Now sometimes suppose here because of these two plates being of same size it is okay, but sometimes this may be of what? 10 mm, this may be of 12 mm. In those cases they may be asking what is the design stress in plate, thinner plate, thicker plate, like this they will be asking, right? So here divided by 250 into 12 mm. So how much it is? 136.32 Newton per mm square. Okay, so this is the simple problem regarding the connections, right? So next problem we'll see where, now this is the problem where two plates are of same thickness. Next we'll see two plates connected which are of different thicknesses, See, this is one more problem. I think this is fourth problem. The previous problem we have lap jointed two plates of same thickness. Here you are supposed to design, okay, two plates 250 by 10 mm with 250 by 8 mm. Okay, so this is 10 mm size thickness plate and this is 8 mm size thickness plate. Okay, and one more condition is there. Their size of the weld is already given, but he here mentioned to give use maximum permissible size of the weld. See, as per size of the weld concerned, you will be having minimum size of the weld, maximum size of the weld, and what we round up. Three conditions will be there. So in the previous problem already size of the weld given, okay, and minimum size of the weld will be depending upon the thickness. If you go back to your previous topic specifications, it is very clearly mentioned in that one. And coming to here in this problem, it is specially mentioned to design, okay, maximum permissible size of the weld is to be designed, right? Now for that we'll try to solve, right? Now here given data, two plates are there, right? Size of thicker plate means 250 by 10 mm. Next, size of thinner plate 250 by 8 mm. Okay, now first we are supposed to find out the maximum size of weld, okay, for thicker plate. I consider this as a S1, which is equals to, now see here, what is this? For square edge, generally the formula is equals to thickness minus 1.5. okay, so S1, what is the thickness? 10 mm minus 1.5 means you have to design directly for this one, don't need to what we say round up to it. Okay, next for thinner plate, for thinner plate, I consider this as a S2, which is 8 mm minus 1.5 means how much it is? It is 6.5 mm, right? Now after this, actual length of weld, is what? Why we are not taking actual length in the problem in the design while calculating is, see, the edges may not be perfectly done. For that you are supposed to deduct, okay, that is equals to 250 mm. So if I can accommodate here, right? So effective length of weld, okay, what is the formula? Effective length LW equals to L minus 2 times of S. Now similarly for thicker plate, I consider it as what? LW1, which is 250 minus 2 into 8.5. Next, for thinner plate, LW2 equals to 250 minus 2 into 6.5. okay, so here comes the that is 250 minus of, so how much you are getting here? It is 233. Next to 250 minus of 2 into 6.5, it is 237 mm, right? This is the now design shear stress in weld. How it is denoted? FWD equals to FU by root 3 into gamma MW. Now workshop, shop means it is, how much it is? 1.25. so ultimate shear stress is given as 410 divided by root 3 into 1.25. okay, so you will be getting around 189.37 Newton per mm square. Next, design strength of welded joint. Design strength of welded joint, that is equals to how much? 0.7 into S1 into LW1 into FWD plus, okay, 0.7 into S2 into LW2 into FWD. Okay. So what is this one? 0.7 into, what is S1? You got 8.5, LW1 is 233 into 189.37 plus 0.7 into 6.5 into, what is this? You got 237 into 189.37. so if I calculate 0.7 into 8.5 into 233 into 189.37 plus 0.7, sorry, 0.7 into 8.5 into plus 0.7 into so I am getting around 466 740.23 newtons. Okay, next he also asked also design maximum permissible, design tensile stress in thinner plate. Okay, design tensile stress in thinner plate means design tensile stress in thinner plate is equals to what? This divided by, what is the area of thinner plate? 250 by 8 mm. So this value divided by So these are the 4 basic problems today we have discussed. So further classes we'll try to solve more number of problems from this chapter. Okay. I think around 3 to 4 classes will be sufficient. 4 classes around will be sufficient to complete. I will try to explain every problem clear cutly. Okay. So those who are watching my videos regularly, please do comment for any mistakes or any question you can raise there. Okay. Thank you.